Okay, this is lesson 1.7b, lines of symmetry. So we're talking about two-dimensional shapes, and they have a symmetry when the other half is like a mirror image of the other. So what we're trying to do is cut objects in half. So a line of symmetry divides a 2D shape into half, and two parts are identical in every way. So if we look at this very first object to the right, it cuts right in half down the middle, and then it's going to be an exact copy on both sides. So ideally what you'd be able to do is you'd be able to take a pair of scissors, cut it down that line. If you flipped it over, it would cover it exactly, okay? Covering it exactly means coinciding. It would coincide. So it says, in other words, a 2D shape has symmetry if a line can be drawn down the center, resulting that the two halves are the same. So it can also be thought of as a fold line. Where would you fold it so it would be exactly in half? Where would you fold it or cut it in half? So just like we said, when you cut it in half or when you fold it in half, both sides are exactly the same. When they're exactly the same, we say it's symmetrical. Okay, that sameness, that big word is symmetrical. So we have different points where we can have symmetry. We could have a horizontal line. Horizontal means left and right. We could have a vertical line going up and down, or we could have oblique lines, which are diagonal lines. So there's different types of lines of symmetry that we're going to be looking at. So if we look below at the page, we're showing the different types of symmetry. So the first one is showing you a vertical line going through. The second one is showing you a horizontal line. And the third one is showing us the diagonal lines in a diamond or a square. You can draw diagonal lines of symmetry. Now, could an example have all three? Yes, it could. A square has all three. So this one right here is a square. So a square would also have a vertical and a horizontal. So that one would actually have 4 lines of symmetry. Okay? But they were just showing the specificness of a diagonal line of symmetry. So what we're going to do on the bottom of the page is we're going to find out where could we cut them in half? Where would we be able to cut those shapes in half? So the very first one, is it going to be up and down? No. Horizontal, exactly. So we're going to find the middle line, and we're going to cut that sucker right in half. So this guy should cut down right down through the middle. Okay? So that guy only has 1 line of symmetry. Okay? 1 line of symmetry. Now we're going to look at the next one. So the next one, if I chop it down the middle, would it work? Yes, it would. So it's got a vertical line of symmetry. What about going through the middle the other way? What about going half? Horizontally? Yes, it does. So it's got 2 lines of symmetry. It's got horizontal and vertical. What about diagonal? Could I cut that one diagonally? Well, let's just think about it for a minute. If I go up to my diagram and I cut it diagonally and I flip this over here, this little bottom piece is going to show up right above here. So it's not going to cover this guy exactly. Because when you want to have it symmetrical, that means it'll cover it exactly. So you'll only see one object. Okay? So the diagonal won't work on that one. Let's look at the next one. Which kinds do I have on that X? It's like a square, yeah. So I've got a vertical one, I have a horizontal one, and I've got diagonals. So this guy's got 4 lines of symmetry. Okay, that guy's got 4 lines of symmetry. Or 4 fold lines, we could say. Okay, once you've got those drawn, we're going to turn the page. Now we're going to draw some. So we want to draw the object. So it says the drawing shows half of a diagram of a figure. It says the dashed line represents a line of symmetry, or that's the fold line. So we want to complete the drawing. How do we do that? What do you think you have to do to complete that drawing? What did we learn about reflections yesterday? When we have a reflection line, how do we know how far away to put it? That's right. It's going to be the exact distance from that middle line. So I'm going to count how many squares away that guy is. He's 2.5 squares away. So I'm going to go 2.5 squares below. Okay, and that'll be my B prime. So there's the other part right there. D prime coming down, or C prime, pardon me, is going to be right down here. They are equal distance from the middle line. They are equal distance from that middle line. That's super important to remember. So again, all you're doing is you're counting how far away the point is from the fold line. So this guy was 2.5 spaces away, so he had to go 2.5 spaces the other way. Okay? So you go towards the fold line, and then you go away from the fold line. All right. Now it says polygons, and we're going to put a word in front of it, regular polygons. Regular polygons mean that every side is the same length. So if you've got a triangle, that means it's an equilateral triangle. Okay, so that means this guy would be a 5, he'd be a 5, he'd be a 5. They're all the same size. If they're regular polygons, they have exactly the same amount of lines of symmetry as they do endpoints, corner points. So how many lines of symmetry can I draw in the triangle? We've got 1. So you always start at a corner and go cutting through the other side in half. So I started a corner and I cut the other side in half. Started a corner, cut the other side in half. Okay, that's how we cut those. So we have 3 lines of symmetry in a triangle. And a triangle has 3 sides. Okay, so a square has how many sides? 4 sides, so it's going to have 4 lines of symmetry. So we've got 1 is vertical, 2 horizontal, and then 3 and 4 are the diagonals. So that means this guy's going to have 4 lines of symmetry. So we can guess now, a pentagon's going to have 5. What about an object that had 10 sides? It would have 10 lines of symmetry. Okay? And this is always when they've got the same amount of sides in terms of the same size. So this guy might be a 6 all the way around. Okay? It means every side is the same length. That's important for us to know. So it says for polygons with even number of sides, the lines of symmetry are drawn through them, opposite of the vertices and midpoints of opposite sides. So that's what I was talking about. So what we did with lines of symmetry is you start at a corner point and you cut the other side in half. That's what we do. Okay? So if I were to draw an object up here, so I'm going to draw a 6-sided object. I'll try and draw a hexagon as best I can here. Or maybe I can put one on. Do they have hexagons? No. Not quite. I wonder if I can make one though. Ooh, look at me go. There we go. There's a hexagon. Okay, so I got 6 sides for a hexagon. So this is my 6-sided hexagon. We're going to pretend that every side is the same length. So what they say is we take our corner points. Those are called vertices. So we take a vertice, and now it's going to cut through the opposite side. Okay? Now, if it's got an even number of vertices, it's going to cut through another vertice. It's going to cut through another point. But if it's an odd number, like we saw the pentagon was 5, it didn't go point to point or corner to corner. It went corner to cutting through a side. So you'll notice that when we look at the ones here, an odd number of sides, so that would be the triangle and the pentagon. When I draw these lines of symmetry, I start at a corner point and then I cut another side in half. So this side right down here, I'm cutting it in half. Okay? Whereas if it's an even number of sides, here I've got 6 sides, it goes corner to corner to cut it in half. Okay? Corner to corner across from it. That's how they get cut in half. So that's how the square got cut in half. The square got cut in half, corner to corner, corner to corner, and then because it's a square, it also gets the up and down. Okay? It got really blurry. Oh, it did get really blurry. Let's just refresh that. Okay, so we are at the last of our sides here. We have 2 final diagrams. For first thing we need to do is count the number of sides. So how many sides does the guy on the left have? Count the number of sides. If you're not sure, you just start by ticking them. 1, 2, 3, 4. Good. This guy's got 10 sides. So it's an even number. If it's an even number, that's where we can take and go corner to opposite corner. Those are going to be lines of symmetry. Corner to opposite corner. Corner to opposite corner. Okay? Corner to opposite corner. Corner to opposite corner. So, how many lines of symmetry would a 10-sided object have? How many corner points? There's 10 corner points. It looks like I only drew 5 because I started with these corner points here, but I drew them to the other corner points. So ideally, if I did these corner points, I'd start here and I'd go back. I'd start here and I'd go back. I'd go here and go back. So really, you've got 10 lines of symmetry because it matters which direction you're going. So this guy is going to have 10 lines of symmetry. How many sides does the second figure have? He's got 7 sides. Good. So 7 sides, it's an odd number. Since this guy is an odd number, it's still going to have 7 lines of symmetry. But let's see how the lines of symmetry work. We're going to have to go corner to cut the side in half. Corner to cut the side in half. Corner to cut the side in half. That's how those ones work. Corner, cut the other side in half. Corner, cut that side in half. And that's what we do the whole way around. Corner, cut the guy in half. And then I got one more over here. Corner, cut the guy in half. Whoa, not that way. Ding-a-ling. Down that way. There we go. So there are 7 lines of symmetry there. Okay? That concludes lesson 1.17 on lines of symmetry. Okay, I'm stopping the video. Come on now, it should re-engage and do its thing. It's going to take a second. Oh boy, it's giving me freezing mode. Don't freeze on me. What's going on? I just stopped it. What's going on? Your tab is being recorded. Auto stop off. I said off.